Hello everyone and welcome back to the Intro to C course MCS 1142. Today is week 4B, June 10th, 2021, which is the 8th session out of 20 sessions. It's the second session of the fourth week of summer semester 2021. Today, and according to the syllabus, we will be going over chapter 5, which is C functions. In this course, we're going to learn how to construct programs modularly using small pieces, which is functions, basically building blocks. We're going to use common math libraries from the C standard library, creating functions from scratch and using functions from the library. We're going to learn how to use mechanisms to pass data between functions. We're going to learn how the function call and return mechanism is supported by the function call stack. We're going to learn about random number generation and recursive functions, which is a function that calls itself. So first things first, why functions? So it's called modularizing. Modularizing. So we use functions in a program just to follow modular designs. They are used to modularize your program for several reasons. One is code organization and management. You basically follow a divide and conquer technique in order to build your program. So you basically break down your program into smaller tasks and then give each task to a function. Let that function work that piece and then return a result. Then you get the result, you do something with it, and then you maybe call another function that's responsible for another task, etc. So you following divide and conquer technique in order to resolve the problem. In order to solve the big problem, you break it down into smaller problems, and then you put each problem in a function that solves that specific smaller problem. And also we use functions for code reusability. Basically, instead of writing the code every time, you write the code once and put it in a function, and then every time you need to use that code, you just call that function instead of writing the entire function all over again. You just call that function. So let's say I have a task of 10 lines. Instead of every time I need to solve that task or do that task, I write those 10 lines. Instead of doing that, I move those 10 lines into one function, and then I call the function in one line, I call it in another line, etc. So this is why we use functions in programming, and they are very helpful. And you're gonna see it everywhere. This is a function. Printf is a function that takes this as an input and does some task under the hood. Behind the scenes, this is doing something. Instead of having the entire code of printf in our main, it's just it resides in somewhere in the code, and then we are using it in main. So today we're going to learn how to use functions, how to pass data to functions, how to get results from functions, how to build your own functions and use them um, in your program. One thing we need to start with is understanding the boss-worker relation between functions. There's always, or that's how it should be. Supposedly, you are gonna always have one boss function and then many worker functions. In your case, and in your level, main is the boss function. Main is responsible of managing everything else. This is where the program runs. This is where you as a student write your code. So this is the boss. This is the manager who manages any other functions. You call functions here, you retrieve results from functions here, you pass those results to another function. So this is the boss function. and everything else is a worker function. In this case, this is a worker function. Hey, worker, I need you to take this input and do something with it. So you're a worker, you take this function, you take this input, you do something with it, and then you return back to me. In this case, this doesn't return anything. It takes the input, it does something with it, it prints it on the screen, and that's it. Main doesn't retrieve anything back from printf, but some functions return values. For example, let's say there is a function that takes 3 inputs and returns the maximum between those 3 inputs. So that function is a worker function that takes 3 numbers as an input and return 1 number. Main will call that function and will give it 3 numbers, and then will wait. Will wait and expect a value back from that function. Once that function is done executing, main will receive the result and move on. So we're going to see that in details. Another thing you need to know is everything inside those functions are local to that function. For example, any variables that are created inside if, only inside printf, only printf has access to them. Main doesn't have access to variables created inside printf. At the same time, all variables created in main do not have printf. So main doesn't have access to variables created in printf, and the vice versa. Printf doesn't have access from inside it. From inside itself, it doesn't have access to variables created in main. So everything created inside a function is local to that function. But yes, we can have global variables. They are called global variables. For example, I'm gonna skip global variables for now until maybe 30 minutes from now. So a function, what is a function? This is the format of a function. So you're gonna have this is how a function looks like. You're gonna have return type, then you're gonna have function name, open parentheses, parameters list. This is a list. Close parentheses, open body, which is curly braces, close body. So this is the basic format of a function. You always have a return type, you always have the function name, and you have parentheses. Inside that parentheses, you have parameters list. This can also be called arguments list, also can be called inputs or input list. So there is a list of values that are input to that function. Everything in this list is accessible from the body of that function. In this case, this function has access to those parameters. So it takes these inputs, does some task with them, and then once it's done, it returns something. The return type could be an integer, it could be a double value, it could be a character, it could be a string, it could be nothing. Some functions do not return anything, like printf. In that case, the return type is a void. So you're gonna have like void, just for example, void main. So this int main returns an integer. This void main means it doesn't return anything. It just runs. For example, displaying a goodbye. Display goodbye, it doesn't return anything. So this is the format for a function. This is called function definition. The first line is called function definition. This is called function body. Anything between the curly braces is the function body. This is the function definition. Let's type an example. I'm gonna follow with the book because they have a simple example and a nice example that I liked, which is a function that returns a square of a number. So let me go ahead and type it first and then explain it. So this function returns an integer, right? Any square of a number or any square of an integer is an integer. And I'm gonna call it square. Then I'm gonna give it an integer. I'm gonna call it a input. A stands for argument. Then I'm gonna open the body. So based on the format I just mentioned, this is the return type, this is the function name, parentheses, and then this is the input. Inside, if I want a square of a number, what is the square of a number? The square of a number is the multiplication of that number by itself. So I'm gonna prepare a result. I'm gonna call it a result, and I'm gonna put L for local. So this variable is local to this function. So int result is what? Is whatever the input is multiplied by whatever the input is. Then I'm gonna return L result. Notice I'm returning L result, which is an integer similar to this case. If this was a decimal, for example, if I say double L result is equal to 1.1, double means decimal. It has decimal value after the point. If I say double result is 1.1 and then I return result, since the return type is an integer, everything after the point will be ignored. So this function will return only 1 because the return type is an integer. So I'm gonna put it back as is, just so you know this small thing. Now I have it. Now this is my worker function and this is my boss function. I'm gonna ask the user to enter a number. Enter a number. Then I'm gonna scan as that number. L input, which is local to main. I'm gonna create input. Then I'm gonna call square, and I'm gonna give it L input. Then I'm gonna print it. Now I on purpose made them to be the same name, but notice this is a block and this is another block. When I double click on this, it highlights only these for me. When I when I double click on this, it highlights these for me. Yes, they are the same name, but this variable is local to square. So this variable is different than this variable. They are different, but they're gonna carry eventually the same value in this case. But I wanted to double make sure that you know about localization. Everything within the block is local to that function. So now I'm gonna run with F10. Square identifier is not found. It has to be above, sorry. Let's put it above for now. So I'm gonna run with F10. Why it has to be above? It has to be above because it's top down, remember? Top down. So by the time it reaches square, even that they are in different blocks, the compiler doesn't know about square unless it's above main. So the compiler will go from top to above, will build square, and then will build main. But when it builds main, it's gonna know about square because it already built it. So F10, enter a number, read the number. I'm gonna enter 4. Then I'm back to here. Result is junk for now. It has junk value. And input is 4. Now notice when I click F10, it jumps to printf, and now the result is 16. I'm gonna display it. Here it is 16. Now, instead of doing F10 at square, I'm gonna do F11. Remember the step in and step over? There was a step into and step over. F10 is a step over. I'm stepping over the line, over the line. In this case, I don't want to step over this line. I want to step into this line. Now notice where my control is gonna go. My control is gonna go to inside the function square. So F11, now it's here. Now it's here. If I hover my mouse at input, it's 4. Why? Because this input came from main. Main sent this input. Yes, it has the same name, but they can have different name. In this case, this is the argument input. In this case, it's the local input. This is the local variable for main. This is the argument variable for square. 4 multiplied by 4 is going to be assigned to result. This result is junk. So F10, now it's 16. It's going to return 16. It's returning the integer back to where? Back to main. So boom, boom. Now I'm back to main. Result is still junk. Now I'm going to step over. It's going to get assigned whatever the result from the square. Then it will display it. And the program will finish. So you see, this is called this call stack. Call stack is when the boss function calls a worker. I'm going to call it worker 1. Then the worker 1 does its magic. Then it returns back to the boss. When I'm in work might also call another worker. This another worker might call another worker. However, when worker 3 is done executing, it doesn't return to boss. First, it returns to whoever called it. Then once this done, it returns to whoever called it. Once it's done, this is done, then it returns to whoever called it. This chain of event or chain of calls is called call stack. It's a stack of calls. This calls this, this calls this, this calls this, then the stack is the 3 calls. I have 3 calls and I start resolving each call. This goes back, so this is done. Then this goes back, then this is done. Then this goes back, then this is done. Then boss will take over and continue. Maybe call another worker. Maybe this worker will call another function. And that's basically it. This is how you build your program based on pieces. This piece is responsible for task X. This piece is responsible for task Y. This is responsible for task Z. This way, if a customer calls you and say, hey, task Z is wrong, something is wrong, I'm getting wrong results in task Z, then you know exactly who's responsible for that task and you go and debug this code. Instead of going through all the codes line by line until you reach task Z, you know exactly where to use it. And in another situation, let's say task X is perfectly put, perfectly done, there are no errors there, and then you are building another program. You're building another program, but it happened that you want to resolve or do the same task. Instead of rewriting the code to resolve X, you just call the function. You call worker 1. You already wrote that code. You don't write it again. You don't rewrite it. You just call the worker. This worker is responsible to solve task X. So this is the basic idea of it. Now I'm going to run it again. I'm going to go into F10. I'm going to go over to square. So run 4. I'm going to step into F10. Now I'm going to open something called call stack. You see, it's called call stack. So let me unpin this, open call stack. Look what call stack says. External code means, so it's from bottom to top. The bottom is where the program started. And you see this arrow, it's where am I right now. So some external code called main started the program. If I double click, see how it highlighted this for me? So it highlighted that at this step, it was line 18. Let me pin. Now you see it. So if I double click, it tells me that this call stack from bottom to top started at here, line 18. Then I double click. Now I'm at line 7. If I had many workers, it's going to show me all the workers here from bottom to top. So this worker called this worker called this worker. So I can go and navigate and see exactly where that call came from. What are the values that were passed? For example, if I double click here and I hover my mouse on input, it tells me at this point, before square was called, input was 4. Oh, okay. What happened now? Now, oh, this is the input. Here's the input 4. Now I'm at here. Go. Now I'm at line 8. Go. Now I'm at line 9. Go. Now I'm back to line 18. Go. Line 20. Line 22. See, this is how you debug your program. This is how you step into your code if something is not working right and you debug your code. Now, with that being said, I'm gonna go over and do another, maybe another example. Let's see what the book did. The book did maximum. This is a good example. The book did a function called maximum. So I'm gonna keep this here. Int result. I'm gonna remove input. I'm gonna call it local first, then second, then third. So what this line is doing? This line is declaring 3 variables. All 3 variables are of the same type. Since they are of the same type, I can just put comma, another name, comma, another name. This is equivalent to saying int L first, int L second, int L third. So these are equivalent. These 3 lines are equivalent to the first line. These 3 lines are equivalent to this. The same way I can initialize by 1, initialize by 2, keep it uninitialized. I can do it in the same line. I can say int L first 1, comma, L second equal 2, comma, L third is uninitialized. Okay. So L first, enter first number. Then I'm gonna read it into first. Then I'm gonna do it second time, third time. Then I'm gonna read it into this, read it into this. So now I'm reading 3 numbers. Then I'm gonna say, and result is get equal get max. And then I'm gonna give max all 3. So L first, L second, L third. Close parentheses, fix the error. There's a red line. Why there's a red line? Because I didn't write that function yet. Identifier getMax is undefined. Means the program is telling me I don't know what you're talking about. I don't know what's getMax. So I go ahead and write max. So what does max do? Max takes 3 inputs and returns 1 input, 1 output. So I go, it returns an integer, right? It takes, I'm going to give it this time another name. So A input 1, int A input 2, int A input 3. What would the body of this function be? So I need the maximum of all 3 numbers. So I'm going to start by grabbing the maximum out of these 2, right? Then I'm going to compare the result with the third one. This way I get the maximum of all 3. So if A input and I'm going to say int max and this is local to square. Oh, I called it square. Get max. So max so far is equal to the first one. So I have three numbers and I start with the first one. If L max so far is greater than the second number, then I want to compare max with the third number, right? If the maximum out of these two is this one, then I'm gonna compare max with the third one. Whoever is max, I'm gonna return it. So if L max so far is greater than A input 3, then I'm gonna return L max so far. Else, if this is not the case, that means A3 is the maximum. So A input 3 return. Now you need to know that if I reach this case and I reach the return keyword, everything is gonna be ignored. This will get out of the function. If return is called, nothing else will be executed in this function. Return will stop this worker from working and return the result to main. Now, this is the case if max so far is greater than 2. But what if it is the opposite? What if it is 2 who is the maximum? Then I'm going to say else. In this case, A2 is greater than max so far. So I'm going to compare A2 with 3. So if A input 2 is greater than L max of, 3, input 3, then I'm going to return 2. Input 2, semicolon. Else, I'm going to return the next one, the other one, which is the final case. So A input 3. Now pause the video, build it, step through it for each cases, and you're going to understand it more. But this is how it would be. There is a simpler way, but I'm going to stick to this for now. Because this shows you all the cases in a clear way. It puts in front of you all the possible cases. There is a simpler way of doing it, but it's gonna confuse you a little bit. If you wanna see it, go through the book. The book has it. So now I'm gonna run it. So notice I don't have any errors. So I'm gonna run with F10. So F10, go read first. In this case, I'm gonna put 5. Then go read second. I'm gonna put 7. Then go read third. I'm gonna put 3. So maximum should be 7. Boom. Now I'm at a get max. I'm gonna step into get max F11 instead of F10. So I go inside the body. So now I'm inside the body. 5, 7, 3. Max is whatever the first one. Hey, is the first one greater than the second one? No, it's not the case. So it will go to the else part. Boom. Hey, since 2 is greater, is 2 greater than last? Yes, it is. Okay, then 2 is the maximum. Boom. Now I step through, result is 7, result will be displayed. Goodbye. Here it is. Let's do another example. I'm gonna step into here. So start, enter first one. I'm gonna do 1, 2, 3. So the last one is the maximum. 1, 2, 3. Now it stepped through, it stopped. Let me minimize this so we see it when it stops. So max so far is 1. If maximum is greater than the second one, then do this, but this case is false, so it goes here. Hey, is 2 greater than 3? No, it's not the case, so it will jump to here. Boom, 3. It returns 3, it displays 3. This is from the book. Now, I want you to know about prototypes. Prototypes means declaring to the compiler that this function exists but its body is somewhere else. For example, if I grab this and put it below main or in a different file than name, the compiler is gonna get annoyed. It's gonna say, hey, I don't know what you mean. Then I tell the compiler, I'm declaring this function for you, and I put it here with a semicolon. As a matter of fact, I don't have to give it names. I'm just providing a prototype for my compiler, just so my compiler knows that this function exists. Then when I call that function, the compiler will know that this function has been built and it's here. So now if I build, it works. Boom. So this line is called function prototype. It's the same as the function first line, but the difference is it has a semicolon. Whenever you see a semicolon, it's a prototype. Whenever you see a curly braces, it's a body. Function definition versus function prototype. And you might get asked in the test. And I showed you function call stacks. Next thing is passing by value versus passing by reference. So let me go back like this. As a matter of fact, let me go back to an example. Let's keep it as this, since you know what's happening. This is taking 3 inputs as copy of those inputs. In other words, if I go ahead, since I took copy of this, I'm gonna say a input increment. So this came as an argument, and this function changed the value. Will this change be affected in main? Will this value be affected by any changes that happen to that value inside getMax? No, it will not. Why? Because main gave getMax, the boss gave the worker copy of the values, not the values itself. So the boss said to the worker, here is a copy of what I have, here is a copy from something else that I have, and here is a copy of something third that I have. Now go and do something with them. So the worker took those copies and did something with them, whether he destroys it, changes it, modifies it. Main does not care because main has its own copy and passed its copy. This is called pass by value. Main passed values to past variables to getMax by value. If you want a worker function to affect the boss function, or maybe like, if let's put it in a better way, because you might have a chain calls. If you want the called function to affect the caller, then you pass by reference. It's called pass by reference, meaning main will pass getMax these 3 variables by reference and giving it the authorization to change those variables to whatever it wants. Hey, getMax, here are 2 numbers, do something with them, and if you change them, it's fine. I'm gonna know about it. So here, I'm gonna go ahead and print all 3. Then I'm gonna print the result. So print, in this case, L first, L second, L third. Second. So I'm gonna go ahead and increment all 3 just so you see it on the screen. New line. Run. So remember, I'm gonna put 2, 4, 6. So the maximum is 6. When maximum is 7. Oh, you know why? Because I incremented it. So let me increment it here. So I incremented 3 and then I returned 3. That's fine. We can do it. We can keep it as is. Just remember that this has been incremented. But what I care about is the values themselves. So when main displayed its own values, yes, the worker function incremented all 3, but main was not affected by that change. When main printed all these 3, it printed them on the old values. 2 became 3 inside worker function. 4 became 5, 6 became 7. But in main, we didn't see that change. Why? Because these variables were passed by value. Now, if I go ahead and add this ampersand character, and this ampersand comes between the type and the name, and then I'm doing it here, and then I'm doing it here. Now I'm passing it by reference, means whatever changes happen inside here, then will be affected by the worker function. This thing has no storage class or type. Let me see. Sorry, maybe I missed. I confused the languages. Does it come here? No, it doesn't come here. It comes here. Yeah, I don't know. It acted strange. So now I'm gonna run again. Go, 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 go. First is 2, 2. Go. Do I have a breakpoint here? Let's put a breakpoint. Go. Oh, 2, 2, 3, 2, 2. 2, 2, 4, 6. Now I'm in max. So max is gonna grab a copy of this. It's gonna increment 1, 2, 3, and then it's gonna do its task. Notice we started with 2 as 2, 2, 3, 2, 2. Now, first inside main knows about the change that happened inside the worker function, and it became 23. Second became 5. Third became 7. So this is passed by reference. Sometimes you need to pass by value, sometimes you need to pass by reference. So it depends on your problem. Now you know how to do it. You add this, and in the function prototype, the function prototype would be without the name and a semicolon. So this is the function prototype of this. It has this ampersand, means whatever happens to this value, tell or inform the caller function. Cool. Next is a function that generates a random number. Random number generations. So remove, 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 remove. Let me go over the topics that we just looked at. So here they are speaking about functions and function prototype. We did that. Then they are speaking about pass by value and pass by reference. And yeah, this is it. So next is drinking some water and going through random number generation. Cool. There is a function provided by, it was stdlib standard library .h. There is a function inside this library that allows you to grab a random value. Random values are very important. I think we went through this in the first session. Anytime you're building a game, especially in games, in industry, for example, like automotive or social. Well, yeah, in social applications, I tried random numbers before. It was like randomly selecting an activity and suggesting it to the user. So there were like a list of activities, right? And you are like a group of users who share the same interest. So I populate list of activities from that interest, and then I pick random and suggest it for you. In the industry, automotive, did I ever use a random number generation? No, mostly in games. In games, you're gonna see it everywhere. In any game you play, there's a random number generation, whether it's a box that you're gonna open and you might get a gift inside that box. There is a randomness in that gift. Sometimes you get this, sometimes you get that, sometimes you get something else, sometimes you don't get anything. So there's some randomness. In PUBG, for example, when you jump from the parachute first in the match make from the very first, whenever the match, anytime you start the match, from the very first to the very end, there is always some randomness, right? Matchmaker will randomly, not very randomly, because you're gonna be with the same level, but will randomly put you with other players. It will pick 99 other players and put you with them, unless you're a team. If you're a team of four, then it's gonna pick 96 random players from the pool of players waiting for a match, and will put you on the same plane, right? Then the plane randomly will have a vector. It will have a direction. Sometimes the plane starts from north to south. Sometimes the plane goes from west to east, sometimes from east to west. So there is some randomness there. Then when you jump and reach the ground and you're gonna enter the first house running before someone shooting you or punching you, you're gonna reach the first box and then you're gonna open that box. First, there is some randomness where the boxes are. You might enter a house, you might not find a box, you might find a box. That box might be in this corner or that corner or in a different room in a random fashion. Then you're gonna open that box and you're gonna find a random weapon. Sometimes it's weapon X, sometimes it's weapon Y, sometimes it's an energy drink, etc. Then throughout the game, there are circles, right? There is a zone. Sometimes the zone is here, sometimes the zone is there. Then it starts getting smaller, smaller. Once it reaches its smallest portion at that period, then it's randomly generated in. So a smaller circle is randomly generated in that circle, and then this is the new zone. You have to run to it. So there is some randomness there too, right? The drops, the airplane comes and it drops a supply box. That supply box comes in a random location. Sometimes the airplane drops it at the beginning of the circle, sometimes at the middle of the circle, sometimes at the end of the circle, and so on and so forth. There's many examples to use random number generation. So how about generating some random numbers for our program? Let's say I want to roll a dice, right? A dice has 6 sides. It has side 1, side 2, side 3, side 4, side 5, side 6. Well, before I go that specific, let's talk generally about the function. The function is called int number. Let's call it a random number. It's called give me rand. This method is from this library. If I go inside it, there is this is the declaration. This is the prototype. You see there is a semicolon. I didn't want to do that. Stop. Okay, so this is the prototype. It's in a header file. If I go to, instead of declaration, I go to definition. Oh, so it doesn't show me. Okay. It doesn't show me. It's very deep in the language that I'm not allowed to see it. So rand, and then I'm gonna print it. Print f d l random number. This random number is gonna be an integer. This random number is between 0 and the maximum integer value. Integer type has 4 bytes. 4 bytes means if we go to the bit representation, remember each byte is 1 bit. So, boom, boom, boom. So I have 8 bytes. 1, 2, 3, 4. 4 bytes. Each byte is 8 bits. So 1, 2, 3, 4, 1, 2, 3, 4. Correct? So let me copy, paste, copy, paste, copy, paste. So this is an integer. It's a 4 byte, which is 32 bits. Now, if all these bits are zeros, means 1, 2, 3, 4, 1, 2, 3, 4. If all these bits are zeros, what is this number? This number evaluates to what? This number is equal 0. Why? Because in the bit representation, since it's a complement of 2's, this represents the digit 1 or the value 1. This represents the value 2. This represents the double of it. It's complement of 2, so it's doubling. 4, 8, 16, 32, 64, 1, 2, 8, and so on, so forth. Double it. What is the double of 128? 512. What is the double of 512? 1024, etc. All the way to a bigger number. Now, if this bit is on, now all bits are off. If this bit is on, this entire string of bits or stream of bits evaluates to 1. For example, if I have this as on, this as on, and this as on, and the rest are the same, what's the evaluation of this? This bit representation evaluates to 1, which is the first bit. It's on, means use it. Do I use 2? No, because it's off. Use 4, so 1 plus, or let's do it the opposite way. 1 plus 4 plus, which bit is on? The 64 is on. So plus 64. This evaluates to 69. So the value 69 is this representation. Now, what if all of them are ones? So I go ahead and say 1, 1, 1, 1, 1, 1, 1, 1. This would be the maximum number in an integer. The maximum number an integer value or integer type can carry is this number, which is a little big. So if I go and I say integer type value range, it's gonna tell me it's from negative this to positive this. If I want the unsigned integer, means without a sign, means from 0 to something. That would be the double of what we just seen. So the double of 2147 is this. Why? Because you have a range, right? You have, imagine the range is 20. If you want, if you want negative in that 20, then you're gonna have minus 10 to plus 10. If you don't want negative in this range, you have 20 options. You either have negative 10, negative 9, negative 8, You have 20 options. If you don't want negative, then it is 0 to double that. So it's now 20. 0, 1, 2, 3, etc. So when all of them are on, in an integer type, the maximum is this number. If I go ahead and I say unsigned int, unsigned int, then the maximum would be what we witnessed, this. So the range of this rand, that's my point. The range of this point, the range of this rand function is from 0 to up to that number we seen, or if it's an int, it's from negative this number to up to this negative. So this function will return any number from these numbers. So I'm gonna go ahead and start it, execute. The random number is 41. If I execute again, it's 41. If I execute again, it's 41. Weird. That's not pretty random, right? It's always generating the same number. So it's not the same number. However, if I do it more than once, so if I do it like this, six times, and I run it, let me put a new line. So 41 number. Actually, rand is from 0 to that number. I think whatever the type is. Anyway, it's not a big deal. So random, right? Random. But if I run again, I'm getting the same sequence. I'm always starting with 41. I'm always ending with 15724. Well, I don't like that. Why I don't like that? Imagine I'm building a card game. Every time I run the program, it shuffles the same way. I don't want it to shuffle the same way. I always want different stuff. Why this is happening? This is happening because under the hood, the way rand works is there is some static values inside it. So let's say there is let's say there's whatever we see, 41, 1536, 1327. Whenever you start your program, the first time you call it, it returns this. The second number, these are like built inside the program, and they are fixed. They are always there. The first time you call it is this. The second time you call it, you get this. The third time you call it, you get this. You close the program, you run it again. First time you call it, you get this. So the way it works is there is some equation here before you receive the result, which is like x plus some constant. So plus constant 1 plus constant 2. Then it gives you the result, right? So if 41, then let's say constant 1 is -1, constant 2 is +1. So they cancel each other. When you first start your program, x is set to 1. Okay, x is set to 1. You call this number, what do you get? 1 minus 1 plus 1, so it's 1. Then 41 multiplied by x equal 41. This is also fixed. When you do the same, you get the same. When you do that, you get the same. So what you need to do is, if you want to get different range, you need to change this x. So if every time I execute my program, I set x to a different value, then I'm gonna always get different value. If this execution it's 1, then I get 41, 1536, 1327. If on the next execution I set it to 2, then I'm gonna get what? I'm gonna get 82, whatever the double of this, whatever the double of this. If on the next execution I set it to 3, then first number is gonna be the triple of 41, the triple of the etc. The way we do it in programming is we always, the X called seed. You always want to seed your generator. You want to seed it in a way that is always unique on each execution. And what is more unique than the time? The time with seconds and milliseconds is a very unique number. Why? At this execution, it is 349.50. At this execution, it is 349.51. At this execution, it's 349.52. So time of the execution is very unique. So I seed my generator with time. And the way you do it is you say srand time null. It's called seeding my generator. In order to use time, I need to use it from a different library. There is a library that gives me current time, and it's called time.h. So time.h provides me this function that gives me current time. So when the line reaches this, it's gonna give me current time of whatever current. So for example, F10. What's current time? 350. Let's say 10 seconds. And I wait 11, 12, 13, 14, 15, 16, 17. When I hit F10, time will return 350.18 and will give it to srand. Srand means seed random. So boom, I seeded random by the time of the execution of that line. So now random is seeded. So if I hit continue, I get this result. I'm gonna take it, copy, and put it here. At this execution, I got these numbers. Now look what when I repeat it, boom. At this execution, I got different numbers. Again, boom, no duplicates. The sequence is not duplicated between executions, which is what I want. Every time the game starts, I want a random shuffle, random airplane, random way of doing things. So in order to do that, you have to seed, okay? With that being said, let's go ahead and do a range of values, because notice these are ugly values. What do you mean by 19,170? What do you mean by 27,163? Well, what do you mean by 3,380? I mean, those are large. If I have only 6 weapons, what's good for me in this? I want a random between 1 and 6. I either want the user to find first weapon or second weapon or third weapon or 4 or 5 or 6. I don't want 3,380. This doesn't make me any good. Well, it does. Absolutely, it does. Why? Because remember the modulo? Remember the modulo operator? The modulo returns the remainder of a specific division. So if I return modulo 6, boom, and I do it again and again and again and again and again and again, whatever number I'm getting, and then I'm doing modulo 6, what does that mean? What would be all my options in this operator? This is gonna, so rand is gonna be either dividable or divisible. What do you say? Dividable. Let's say dividable. Rand, whatever the number is either divisible by 0 with a divisible by 6 with a remainder 0, means it's equal, it's even, or it's gonna be divisible by 6 with a 1 remainder, or divisible by 6 with 2, or divisible with 3, divisible with 4, divisible with 5, and that's it. Why? Because if it is divisible by 6, I'm not gonna get 6 as a remainder, I'm going to get 0 as a remainder. So if I go here again, let's take this example. Let's say I receive the random number 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? I have all the way to max int, whatever the maximum integer is, what we saw here. So whatever number I get, what is the modulo 6 for this one? Modulo 6 of this one is 1. What is modulo 6 of this one? It is 2. What is for this one? It is 3. For this one, it is 4. For this one, it is 5. For this one, is it 6? No, I can't get a 6 because this is divisible by 6. That means the remainder is 0. Then back again, 1, 2, 3, 4, 5, then 0. So the sequence I'm getting is always between 0 and 1. So if I do modulo 6, this will always get me one value of the following list: 0 or 1 or 2 or 3 or 4 or 5, and that's it. There is no way I get any other uh, number. Now, in the case of a dice, I don't have a side with a 0, but I still want 6 sides like here. So what do? I add 1 to it. So I'm telling my I'm gonna tell my program +1 means if this returns 0, add 1 to it, meaning this set will become this set. 1, 2, 3, 4, 5, 6. Done. See what I did there? So this, based on this this explanation, this instruction will return one of these values. It's either gonna return 0 or 1 or 2 or 3 or 4 or 5. Once I get one of these, I'm adding 1 to it. That means this set is now mapped to this set. So if I get a number that is divisible by 6, then the remainder is 0. Add 1 to it, then I got 1. If it's divisible by 6 and remainder is 1, now means it's 2, 3, 4, 5. So this can be the rolling of a dice. If I run my program, actually, let's add the ones to the rest. Boom, 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 boom. So first roll, I got side 4. Second roll, I got side 4. Third, I got 6, 6, 4, 6. Well, let's try again. Now I got side 1, side 3, side 6, side 5, side 4. Let's say I have 6 weapons in the game, in PUBG, let's say. The first time they opened the first time they opened the box, I go and ask my program to give me a random number. Then I pick that weapon. If the random number is 1, then I pick the first weapon and show it to the player. The next time he goes and picks another box, and I go to my generator and say, hey, give me another random number. He gives me 3. Okay, pick third weapon and give it to the user. 6, 5. Maybe it's a list of many things: energy drinks, armor, weapons, medicine, right? Anytime I run my program, it returns me a number within my range, and I proceed and pick that from the items and show it to the user. So what if I have 15 items? Means remainder 15 plus 1. This will always give me a value between 1 and 15. Why? Because this will give me a value between 0 and 14. And then I'm adding 1 to whatever I get, means I'm mapping it to 1 to 16. So let's run. Oh. So 3, 6, 3, 5, 6, 3. It happened that we didn't get a large number, so let's try. Oh no, we have to do it everywhere else. This will give me a number between 1 and 15. 13, 11, 12, 14, 1, 3. Again. 11, 6, 8, 4, 1, 12. Again. 4, 4, 15, 2, 7, 11. Cool. This is random number generation, so now you know it. With that being said, this is what you need to do. For homework 4 that you get assigned today, no, forget about the research. So build a program that does the following instruction. I want you to generate a random number between 1 and 5. Very simple. Then I want you to tell the user if that number is odd or even. Your way. Find a way to figure out if a number is odd or even, right? And try to do it as simple as possible. Don't do like 5 if else statement where it says if 1 then it's odd, if 2 it's even, if 3. Try to do it in a smart way. Also, like using operators, you have modulo operator, etc. Then I want you to ask the user to guess that number. And as long as the user is not guessing, the program will keep asking the user. Enter a number. The user enters the number, you check. Is this the right number? Is this the number that I guessed or the program guessed? If that is the number, you display congratulations. If it's not, then you repeat. So you're going to have some loop, right? There's a loop, and the condition is as long as the user didn't guess the number. As long as the entered value is not equal to something, you're going to keep asking the user, and the program will run at least once. Remember the types of loops. Your program will at least once ask the user for an input, then it will check, did the user guess it right? If yes, do something else, repeat, do it another, second time, third time. So your program will run at least once and will keep running as long as the user didn't guess the number. Don't forget to use the seeding because it's very important, and that would be it for today. Let me know if you have any questions or if you need any help, and good luck.